Okay, so here we're going to graph this cosecant function. So the first thing you do when you're going to be graphing this is to identify the variables that it talks about in the general form of the equation, which is y equals a cosecant b times x minus c plus d. So a is equal to 2, b is equal to pi, c is equal to 1, and d is equal to 1. Now that we have that, we don't need this anymore. Now when you're graphing a cosecant equation, the first thing you're actually going to do is graph a sine equation, because sine is the reciprocal function. Sine graphs normally start at 0, 0, the origin, but since we have c and d values that aren't 0, the whole graph has been shifted up and over. So we take would normally be 0 and 0, but now we have to add our c and d functions. C is added to the x coordinate, and d is added to the y. So our graph will actually start at 1, 1. So we're going to put that on there, 1, 1. The next thing we need to find is the period. A period is always 5 points of data long, and it's also equivalent to 1 trip around the unit circle. That's all. We're only going to graph one period in this. To find the period, you use the equation period is equal to 2 pi over b. In this case, b is pi, so we have 2 pi over pi, which is equal to 2. So that's our entire graph is going to be too long. Since we started at 1, our graph is actually going to go 1, 1, 2, 3, and the last point will be there on 3. See the other marker. 3. Yay, 3. Okay. So we have 2 points now, the beginning and the end, but we need to find 3 more for it to be a full graph. All the points on the period are going to be equally spaced. So the third point is going to be halfway between 1 and 3. So 1 plus 3 is equal to 4 divided by 2 is 2. So we're going to have another point right there at 2. We'll also have points at 1.5 and 2.5. Okay. So we'll just draw in little lines for those points as well. So now we have the x-coordinates of all our points, but we don't know the y-coordinates therewith. The first thing we need to do to find that out is to find the amplitude. The amplitude is how high above and how high below and how far below the middle point, the intercept, the graph is going to go. So to do that, we find the absolute value of a. Absolute value of 2 is just 2. So we're going to go 2 above 1, so also at 3, and we're going to go 2 below 1, which is negative 1. Now this is a positive sine graph, so it's going to start at an intercept, go to a maximum, come back to an intercept, to the minimum, and back to the intercept. And that is the sine graph. But we're actually looking for a cosecant graph. So the next thing we have to do is add asymptotes at the intercepts. Asymptotes are shown as dotted lines, and they are points which your graph will approach but never actually touch. Now the actual cosecant graph is little U-shapes that come off facing away from the sine graph, come off the maximum and minimum points. So that's sort of what we have. Now we don't need the rest of the sine graph anymore. So I'm just going to erase it and fix the axis. And there we have the graphed equation.